All right, welcome to exercise 1.4. So we're just going to work through a couple of visualizations of panel data. And we're particularly going to work in long format panel data. In exercise 1.5, I'm going to show you an example of why we care about wide format panel data, which is going to give us a much better picture of certain kinds of things. So we'll come to that when we do. You'll remember the first step, as always, when we work with our exercises, is to go up here, click on Save a Copy in Drive, and this just creates a copy for yourself. So the first thing to do once we've loaded this on our own is to run the cell. Now, what we're working through is thinking about panel data, and what we're going to do is visualize a lot of the summaries of the data set we'd worked with in the slides. So we're going to talk through this data set, coffee sales receipts, that we had worked through in the slides. So here I have the data set to load, but I've copied all this data over to the notebook. Okay, so here's the idea. We just want to use this data set of transactions by coffee shop throughout the day to help inform where to think about hiring a barista. So this is like thinking about labor demand. So I'm gonna run this for cell just to load the data set. And usually when I work with data sets, I like to print out a summary of the data set at the top. So we can do this either just by running the cell, the data set itself and printing out everything, or as I like to do, sales.head, which just prints out a header. And what this does is gives us a picture of the variables and what's contained in each one of them. So here I have transaction ID, staff ID, customer ID, but for our purposes, the main ones we're interested in are hours and shop. And all we're going to do is go through and count the number of transactions that are happening. We're not going to worry about the quantity per hour. So here we have a measure of quantity. So in transaction ID 11, we actually had 2 things purchased. But what we're going to do is just count the number of rows. So thinking about the number of times someone has to be rung up at the cash register. Okay, so the first question we have is which shop is the busiest? So if you remember from the slides, what we wanted to do here was create a bar chart. And as we go through this, I've given you some hints here, but you can think about the visualization tool you would use in this case. So here, I want to create a bar chart, and I have the header printed out here, which helps sort of think about the things we're about to do. Okay, so I want a bar chart. We've been working with Seaborn syntax, so if you feel familiar with this or are starting to feel familiar with this, creating a bar chart is pretty intuitive in a lot of ways. All we want to do is call Seaborn, so SNS dot whatever we're looking at. In this case, we want to go through and count the number of transactions that are happening according to a categorical variable. So in this case, that's shop. And if you remember from the beginning of the semester, we worked with count plot. So I have count plot, which I'm just pulling out of Seaborn. The data set we're working with is sales, so I'm just going to enter that here. So sales. And then on the horizontal axis, I want to set up the category that we'll be counting. So in this case, that's shop. So X is equal to shop. And if I run that, I get a bar chart. What I did in the slides, I included separate colors by category. You can do this. I think in that example, it was nicer to look at, but you don't necessarily need to. This figure shows everything that we need it to. But yeah, if you wanted to add a hue, we could just change the color based on the shop. Okay. And then for the second one, what time of day is the busiest? We just want to create a histogram showing the distribution of transactions across periods of time. So in this case, we have sns.histplot. And if you remember the sort of grammar of Seaborn, we want to give it the data set first. So this is sales. And then we want the horizontal axis to be represented as x. So this is x is equal to, is it hours? And when I run this, I get a histogram that looks like this. This is fine. This is not a great histogram. It's breaking up the periods into intervals that are shorter than 1 hour. So what I want to do is actually set the bins so that they're exactly equal to 1 hour. So I'm going to say bins is equal to, and then I just want to have a list going from 0 all the way up to 24 for the different hours. And Python has a handy little function called range. So this just gives us a list going from the first number that we give it, so in this case that'll be 0, all the way up until the last number, 24. And then we'll index it by 1. One little note here is the number we give it is when it stops, but the range won't include that last number. Just one of the little peculiarities of range. So if I want to include 24, then I should tell it 25. So when I run this, it includes bins that are exactly 1 hour long. Okay. We want distributions by shop. Now, one of the tricks you'll learn is it's often easier just to copy code instead of rewriting it. So we're going to create a histogram, and I want this to be broken up by shop. If you remember, one of the core ideas in Seaborn is that we can give it separate hues, and Seaborn will interpret that as wanting separate colors broken out by a categorical variable. So in this case, I want to give it hue is equal to shop. And if I run this, it will give us a histogram by shop. So each shop will have a separate color. And you'll remember this from the slides. This is not a very good figure. It's pretty challenging to read. We can definitely see that coffee shop C is the most popular in the morning. So the busiest shop shift is at coffee shop C in the morning. But this is not great. So we want to do something better, like we talked about. One thing we could do is a faceted histogram. This is one I don't use so often, so I'm going to hop over to the slides and look at the code I have here. So this is one approach here. We have what we call a dis plot. There's some other options, but this is the one we'll work with here. But I just want to talk you through what I've included here. So this is SNS, as always. Displot is just a type of visualization that we can use in this case for faceting. We have sales, and then the horizontal axis is hours. So just like we did with the histogram, we're just going to have hours on the horizontal axis. We'll have the columns, so we're going to set up the separate facets horizontally. So we have each histogram going in one of the columns. So this sets it up horizontally. And then we have our bins. Okay, so that looks like this. We could also do rel plot, I think. Nope. Okay, so the last thing we're going to do is go through two approaches to constructing a multi-line graph. The first approach, we're actually going to go through and create a summary table, which is a little bit more involved, and there are sort of a couple of extra steps. Once we construct a summary table, we can then use that summary table to construct a multi-line graph. So this will be a couple of steps. The reason we're doing it this way first is so that I can show you how to create a summary table. Once we do this, I'm going to then show you the shortcut for how we can skip creating the summary table and just go directly to the multi-line graph, which in some cases can be nicer. Okay, so Gemini knows exactly where we're going. Shop and its hour. So this treats shop A differently than hour 13 at shop B. And it also treats hour 13 at shop A different from hour 14 at shop A. So we're breaking out the data based on the shop hour pairing. And then here, we're just applying another function to that thing, and we're getting the size of each one of the groups. And then this last bit is just to sort of condense it into a summary table. These are a lot of steps, and I don't remember how to do these steps every time. Usually I will either look it up on the internet, I'll refer to code I've already written, or I'll use an AI. This is how we've written code for forever, and it's very okay to reference materials when you're writing code. In fact, it's really the easiest way to write code. Okay, so what I'm going to do is just copy this to the clipboard and hop on over. So I'm going to paste this in and run this. And what we can see here is I've gone through and counted the number of transactions that are happening, for example, at shop A in hour 7. How many transactions are happening? Well, the answer to that question is 1,383. And I've done this for every coffee shop hour combination. So shop B at hour 8 will have a different number. Okay, so this is nice. This is a nice little summary table. Sometimes this in itself is really helpful, but in general, summary tables like this are not going to be as communicative as a figure. And so what we turn to next is the line plot. Okay, so so far, all of our visualizations have used the raw data set. In this case, what we're going to do is use the summary table as our data set. So what I want to do is construct a multi-line plot. So I'm going to say sns.lineplot, and then as the data set, and then the vertical axis is going to be counts. So I want y to be equal to counts, or count. And you'll notice here, this is different than a histogram because we do have to specify the vertical axis. A histogram is going through and behind the scenes is counting up how many rows fall into each one of the categories that we've specified as the horizontal axis. Here, because this is a line graph, we have to actually tell it what the vertical axis should be. And in this case, that's count. But then I also want 3 separate lines, one for each one of the coffee shops. So this is hue. So we're going to set hue equal to shop. Okay, so really it's that simple. And when I run this, I get a figure that looks like this. And this is pretty good. We have a separate line for each one of the coffee shops. But you'll notice we went through a bit of work to create the summary table, which in some cases is very useful on its own. We then used the summary table to construct the line plot. But I'm going to show you a bit of a trick built into Seaborn that allows us to skip that step of creating the summary table. What we're going to do is actually just use a hist plot and then tweak a few parameters to make it nicer. Gemini here can be really useful, but I want to talk you through what we're seeing. If I hit tab, this will auto accept. This is the current state of our technology. Here, I'm going to use sns.histplot, so just our classic hist plot. I'm going to give it the data set as always, so this is sales. And you'll notice here we're using the raw data and not the summary table. Then on the horizontal axis, I want to give it hours. So we're thinking about a line plot, multi-line plot, and we want hours. Or we're thinking about a histogram. So now we have histograms for each one of the coffee shops. And I'm gonna make this nicer with bins is equal to range 0 to 24 or 25. Doesn't matter in this case. And if I run this, we get our old figure that we constructed. But the difference, what I'm gonna do differently in this case is I'm actually going to tell Python to drop the bins. So it's just going to sort of construct just a shape, putting a line at each one of the top of the bins, and then just filling in the rest. So I think, if I remember correctly, is this element is equal to poly, and if I run this, I get this thing, which already is a lot easier to read. But we can take this one step further by removing the fill inside each of these elements. So I'm going to say fill is equal to false. If I run that, I get a nice line plot, just like the one I showed you in the figure, or in the slides. So what we've gone through here is just how to think about constructing figures. In the slides, we talked about how to think about which figure to select for which question, given the data set that we have at hand. Okay, so in the next one, we're going to turn to thinking about panel data, but from a different perspective. Sometimes long format panel data is the right choice. In fact, it's often the right choice. But there are a lot of situations where we want a different structure to our panel data. And that's where we're turning to next. So I'll see you in the next one.